So you might be fascinated by the name, and I'll just continue with it.
Thanks a lot. So who of you has to leave at 3 p.m. sharp? So can we take until 3:10 or something? Yeah? Okay. So that means actually I have to cover 8-hour session in only 30 minutes instead of 20. I want to show you some downstream analytics stuff. And since you might be a bit tired, we will start with the boom, boom, shake, shake demonstration. And I will later tell you what's all about it. So for those who want to participate, please take your mobile and open a link, which I will show you in a second. And basically what you have to do when you open the link, it will load a mobile website. It will ask you for two things. One is a unique user ID. Just put 8 small characters there. And please remember that user ID. And the second is a password. You don't have to remember it, but it's also, please use 8 small characters, okay? No capitals and no numbers. And then what it will do is it will use 2 JavaScript libraries. One JavaScript library will read the accelerometer sensor data from your smartphone, and the second one will transfer the data using MQTT to the IBM Watson IoT platform, and that's a kind of proof that it is completely open, because any device which can speak MQTT is capable of interacting with the IBM Watson IoT platform. Okay, so. And I will show you some downstream analytics using Node-RED and Spark, and then I will explain later what Spark and all that stuff is doing. So that's the URL. And I think it's first come, first serve, because the Watson IoT platform service is running in my free tier. So it's free for everyone, but it's limited to 20 devices. So the first 20 can participate. The rest will get an error message. Okay, so let's have a look how this looks like. So you're already, yeah, sending data. Okay, so some of you are already sending data. Let's do the following. Let's deactivate the debug. And when I click on deploy, it will be stored to a new database in Apache CouchDB running on IBM Cloud. And let's do it for 10 seconds. So when it starts, you have to shake your device as hard as possible. And since we are measuring 3 dimensions, you have to shake it in a 3-dimensional pattern. Okay? And I will basically sing that you are motivated a bit, that you are a bit more motivated, okay? And when I stop singing, you can basically stop, because then I will just stop recording of data, okay? So, and 1, 2, 3, boom, boom, shake, shake, boom, boom, shake, shake, boom, boom, shake, shake. You're tired. You won't win anything with that. Boom, boom, shake, shake, boom, boom. It looks like you are kind of cleaning the house and, oh yeah, I'm like a bit tired, cleaning the window. Okay. Maybe, oh, what happens here? I think you get a second chance. Oh, I think you're way too late for the link, but you can try. It's boom, boom, shake, shake, and the first part is ibm.biz. Let's try it again. Okay, no error message. Again, boom, boom, shake, shake, boom. boom, boom, shake, shake. Three-dimensional pattern. Oh, what happens? Yeah, it was working 3 minutes ago. So, okay, now it seems, yeah. Okay, so boom, boom, shake, shake, boom, boom, shake, shake, boom, boom. Oh, shake harder, shake harder. I have to videotape this. Yeah, I never managed it. Okay, now. Boom, boom, shake, shake, boom, boom, shake, shake, boom, boom, shake, shake. Okay, I stop recording. 1 second. So let's see what happened. I will tell you briefly what happened. So I have, by the way, migrated this demo from using a relational database to a NoSQL database in 2 minutes. Like you have been enjoying lunch, I just did that. I didn't have to create any tables or something because NoSQL is all lazy. That means, as you have seen here, I have created a table called shake3, which is now present in the CouchDB, but I don't access it using CouchDB. I access it using, let me sit down, the IBM Data Science Experience Workbench, which is based on Apache Spark and Python and Jupyter. I will tell you what's all about this later, but so what I'm doing here is I'm accessing the CouchDB, and that's the data. Okay, so that's an example of the sensor ID Editi Yamoto. Who is that? Okay, so that's a pretty good value, but only for one axis. Ah, for the second as well. Yeah, okay, you somehow had a three-dimensional pattern. You see that you have also negative values, so we have to take this into account. So as you can see here, I'm running against JSON data, sitting in NoSQL, and issuing SQL against the NoSQL database from Apache Spark. I will show you later how this works, but now let's implement it. So I get rid of that, because I want that you help me implementing a SQL query, finding out the winner, okay? I have to store this somewhere, just in case. So to run a SQL query, it's basically this Python code. So let's start. So you have seen that the accelerometer values for each axis are stored as integer values from minus something to plus something. So we have to take the absolute value, because negative acceleration is also energy. And if we want to calculate the energy on a time series, we can basically just calculate the integral. So for those who are still familiar with high school math, and in order to approximate the integral, we can just take that samples which we are creating here. We are sampling 10 times a second on the function, and it's basically the surface above and beyond the function, which is the energy, and then we have to sum it up for each of the 3 axes. So let's do that. So we sum. And then we add all the 3 dimensions up. X, Y, Z. We call it energy. And of course we have to group. The cool thing is everybody who knows Python and SQL can work with that. And that's actually a key thing, because if you want to hire somebody who does it in Scala, you will have a hard time, no? Everybody knows Python and everybody knows SQL. And since everything comes as a service from IBM, you don't need the folks for operations of the Spark cluster. So we group by sensor ID, and of course, we have to select it. Sensor ID, and then we order by energy. Descending, and then we should get the winner. No, because I have accessed this Cloudant database, but I have registered it as a temporary table in that name. But thanks a lot. But I think you are the winner anyways, but let's see. So star means the process is running. No, it's not you, it's Rups, but nearly. Oh, okay. So, okay, that's one thing. And now let's use this to create something useful. And since you promised you will stay another 15 minutes, I have time to tell you about something of the technology. So who of you is familiar with Apache Spark? Nobody. Yesterday I was giving the talk at a meetup and I had like 2/3 of the guys. So Apache Spark is an open source data processing framework developed by the UC Berkeley in California, and it is a top-level Apache project, and it's the most active Apache project worldwide. So the basic idea is if you want to process a lot of data, you process this. Any Java programmers in here? Any programmers in here? Okay. So if you have a Java process, you are limited to the resources of a single node, a single server. So if you want to parallelize this, you can put the executor Java processes on the server, and you can run them in parallel. And you can also distribute them among compute nodes. And that is actually what Apache Spark is doing. And either using a single, some sort of storage provider. So we are using, for example, Cloudant in this case, but we could also use something like HDFS, which is a distributed cluster file system. Okay. The central data structure here is a RDD, which is nothing else than an array or collection of data, but this array is distributed on the cluster nodes. It resides in main memory. So if you have 100 servers with 100 GB of data, you have 10K or 10 terabytes of main memory. And you can easily cycle this up in the cloud for a couple of hours for less than $100. And in case the data doesn't fit in the distributed main memory, it will get spilled to disk automatically. So just another thing which I want to show before. So I've shown you Spark SQL now, because everybody knows. Who knows SQL in this room? Okay. So now I'm a bit more relaxed. So the RDD is the central distributed data structure, and then we encapsulate this in a so-called data frame, and you can run either programmatically relational queries against it using Scala, Python, R, or Java, or you can run SQL queries against it, and that results in the basically same execution. There's dataset, I won't cover that, it only works with Scala and Java. So the thing is, those executions are optimized based on statistics. It basically works somehow like a relational database engine. But you can have a petabyte of data and 100 servers, and you still have the benefits of a relational database engine for analytics workflows. So I will just skip the details here and just dive into analysis. And I have actually created this analysis while you have been eating lunch as well. So it's a really, really straightforward thing. So let's save this. And so you are seeing here the data science experience, which is the IBM product, but it uses Jupyter, which is an open source UI. And it uses Apache Spark in the background. So from the data you have seen before, from the test data generator, I have created a little application in order to recognize outliers. So if the temperature is too high. So what I use there is, so I still have to run again this code here. This code will connect to another cloud and database. Actually, it's the database which the guys created. So this is still running. I register the table as a SQL table here. So now I walk you briefly through those two SQL statements. So I'm calculating the outliers based on algorithm called moving C-score. Okay, I just tell you what moving C-score is. So who of you knows what mean and standard deviation is? Okay, so for those who don't know, the mean is basically more or less the average. So you sum up all your values and then you divide it by the number of values. Then you get the average value. Standard deviation is a bit more complicated, but basically it gives you the distribution of the values among the mean. So the lower the standard deviation is, the closer all values are on the mean. So for example, if you have a time series of 100 data points and all is 22 degrees, you will have a standard deviation of 0. Okay? So now and for the C-score, we just need the actual value minus the mean divided by the standard deviation, and then we get a score, an anomaly score for each value. And the moving C-score is calculating this on a window. So who of you knows what a window is? No, it's not NumPy, it's PySpark. Yeah. So this is actually a window. No, a window is basically, if you are in stream processing, a window is a subset of data where you can run aggregations on. And that means you actually don't look at the whole data set, you just look at the n past examples. I'm looking at the past 30 examples, basically, which means I have a so-called sliding window, and it's a time-based sliding window because I get a sample every second. Otherwise, it will be a count-based sliding window. So let's go back to the calculations. So I create here the sliding window by, you see it even, so I found this out during you have been eating. So it's a trauma now. You have been eating and I've been working, so I tell you 3 times already. So I have created this little window here by just generating rows because I just order by timestamp descending. So that means I have row numbers from 1 to n, and the newest item has row number 1. That means I can just take the rows, the first 30 rows, and on the first 30 rows, excuse me? This order by statement matters because if you don't order, you get the 30 oldest values always. But I want to, yeah, I want the 30 newest because I'm not interested if the temperature in this room was low 2 years ago. So that's why I order by timestamp. Yeah, and let's run this, or I show you that. So if nothing happens, you have always the same temperature, the standard deviation is 0 and the mean is 20, for example. And what I now do is I calculate the C-score. If you remember, the C-score is the actual value minus mean divided by standard deviation. So I inject the, actually I was calculating this wrong. No, it's correct. No, it's wrong. The data, that's the actual temperature. And I would have to subtract the mean, so I have to change this later. And then I divide by the standard deviation, and I had to insert this little term here because eventually the standard deviation is 0, and you cannot divide by 0. So that was a quick workaround. So that is the C-score for each temperature entry. And then, of course, I get the temperature itself. and I order again by timestamp descending. That's some Python magic, so I can, that's really cool in Python, also available in Scala, not in Java. You can just add or inject those two values in the string using those two placeholders. And then I run it, okay? So let's run this. So you get a mean of 20 and a standard deviation of 0.25. Somebody messed around with a... No, okay. I promise it was working before, so let's give it a try. So I will now set this to 40, so it will slowly increase. And I have to run it again. Do you see it's working. It's increasing, and the z-score is also increasing. So the z-score of 0 basically means it's not an outlier. And looking at the window for the last 30 seconds, you see that value is increasing. Yeah, okay, so that was basically my demonstration. So you could, for example, then schedule this and run it every hour, and as a result write it back to another storage engine and query that. And the thing you have seen before, the real-time insights, actually is running on top of Apache Spark, and on the roadmap you will have a lot more of advanced analytics, so stuff which is more advanced than just setting thresholds. And on the device side, by the way, it's also running on open source. It's a project called Apache Quarks, which IBM released. It's a embedded device streaming engine, which basically runs the job in parallel. And just as a last side note, those calculations here, they can be run in a distributed fashion. So you don't have to send all the data to the cloud if you don't like. You can calculate the z-score, subsets of the z-score on the device, send the data, only the aggregated values upstream, and do the final calculation in the cloud. And that's a topic which is also interesting. You will save a lot of network bandwidth and storage. Okay, so 2 minutes left, 2 minutes for questions. No questions? Yeah? It's all running in IBM Bluemix. It's more easy. You can, of course, distribute it among different cloud providers and all, but you are faster if you just take everything from there. You have Node-RED as your central data integration hub and do it there, yeah. But it's open. It's no. So since I've taken out the relational database, which was based on DB2, and put in CouchDB, it's a complete end-to-end open source, open standards-based solution. The notebook itself is also running in Bluemix. Yeah. Coursera is basically, yeah, the thing is we have one course on Coursera which is already online. It's basically telling you how to, it's from IBM. So IBM is the first non-academic institution which has been accepted by Coursera, and that's the first course. So it's about how to get the data from the device to the cloud. And we are running now 3 other courses. The first one will be published in 2 weeks. It's about exploratory data analysis. The next one is on time series analytics, and the last one is on AI methods on IoT sensor data. And it's a specialization which we are creating on Coursera. Yes, yes. No, that will be present soon in the real-time insights. There will be much more functions. So for example, calculating the moving z-score will be a built-in function in real-time insights which you can choose and pick. Yeah, maybe if they name it like something anomaly detection algorithm number 1 and give you some documentation, that's basically how it will look like most likely. Yeah. Because there are many other things. So I'm in the AI thing. Yeah. Yeah, but that we will take care of. So we have, for example, I have a demo running using a neural network for anomaly detection, and I've spoken to the. It's a so-called autoencoder. It's a new. I can talk to you later about this, but basically this will also be part of real-time insights. Most likely, I've spoken to the lab and they want to pick it up. So you can choose from, let's say, cheap, fast-running, basic anomaly detection algorithms up to more complex and computationally intensive algorithms based on neural networks. Other questions? Okay. So wedding is over. Thanks a lot for coming. Oh, I want to show you something, the recipes. Can you do it?
Yeah, okay. I think before the recipes, so I think one quick thing. So guys, I think for guys who are still having your laptop, so if you just one more task that you have, if you can go back to the application. So as with any session that we do, like what is the end that comes into, right? Give your feedback. So based on whatever you saw what the whole workshop was on, so what was your genuine feedback? If you can go to this link and give in your feedback, it will actually matter a lot, even how we can improve and what are the good things that you found here. Okay, so I think it will be really great if you can go to this link and give your genuine feedbacks. And I think one part that we also had as part of this was, yeah. So if you actually can go to IBM IoT recipes, so the first link that does come up. So I think there was a lot of questions on like how do I connect my devices to the Watson IoT platform, right? So if you can go to this website, so that has a list of all the supported devices that for which we already have written some code, so that all you have to do is just put in the code into your device and it starts sending the data to the Watson IoT. Like devices like Raspberry Pi, Intel Edison. I think are you showing Intel Edison? Okay, so something similar to so all these devices that you can actually start writing a code and start sending the data. So that is what these recipes will help you. So there's a bunch of code that you can actually start using, and for ones that are not there, if you want to start developing, so there's a bunch of SDKs that we also provide, like for all the most important languages like your embedded C, Python, Node.js, Java. All you have to do is just implement the SDK and your now device becomes IoTized, right? So basically you can start communicating to the Watson IoT platform. So I think, yeah, that's all I had. So I think Prasanna, so Prasanna is there. So all of us will be still here. If you have any other questions, please feel free to ask us anything. Okay? Yep. Anything else? Yeah. Thank you. Thank you, guys. And I think the next, I think we almost took like 15 minutes, but yeah. Thank you. Yeah, yeah. Yeah, so a quick again, a reminder to please give your feedback on the same form that we just gave. Thank you.